Hi everyone, it's Alex from Risk Academy, and it's a great pleasure for me to be at the Probability Management Conference in San Jose, California, and I'm speaking to Brian Putt. Brian, can you tell us a little bit about yourself?
Well, Alex, I spent 41 years at Chevron, doing a range of activities, the last 25 of which was developing decision analysis or decision quality, which was looking at assessing risk of the major capital projects that Chevron does. At one point in time, we were spending $40 billion a year on capital projects. So that's really a lot of money.
Yep.
And the question is, how do you spend that the best, in the best way to get the most money for the least amount of risk?
Mm-hmm.
And the oil and gas industry is probably the riskiest industry you could be in. When you think about exploration, and literally you can spend tens, hundreds of millions of dollars drilling a well, which may only have a 1 in 5 chance of being successful. And most of us, even moderate-sized companies, don't want to flip that coin for a 1 in 5 chance for $100 million. So it's a very risky business. So understanding that risk is important to the industry.
And what is risk to you? Because you seem to have that amazing foundation to apply the decision science kind of where it belongs, to apply the proper risk management. I mean, for our listeners, they know that I call it risk management too, but this is what risk management was always about. So what does risk mean to you?
Well, that's a very good question, because there's two terms to think about. One is risk, and one is uncertainty. Mm-hmm. We live in a world of uncertainty. Everything is uncertain. The cost of something is uncertain. As Sam Savage would talk about, you know, what is the risk of IBM stock going down, right? Mm-hmm. Well, to you, there may be a risk. To me, going down is actually a benefit because I shorted the stock. And so it's very difficult to say what risk is. There's not one definition. It depends upon the organization. It probably depends upon the decision maker. Mm-hmm. Sometimes people talk about risk as being the probability of losing money, but it may be gaining less than some hurdle rate that you have. Mm-hmm. You know, you may have a 15% rate of return hurdle rate. Right? Yep. So it becomes very difficult to say that. But I think it's also important to understand just the uncertainty, the range of values that can occur, even if they're all positive, in making the decisions.
And what are some of the tools? Because Chevron is a well-known global case of merging the decision science with the probability management and applying that to make better, risk-based decisions, for the lack of a better word. What are some of the tools that you've been using throughout your career? I mean, I'm guessing it's probably something more sophisticated than heat maps and multiply and likelihood and consequences.
Absolutely. Well, I think it all has to start with a framing exercise, and that is, rather than starting off with building a model, we need to understand what are the problems we're trying to address, what are the decisions that we can make. And we'll do that by having some sort of issue raising with a group of people. In the petroleum industry, you might have subsurface, you may have facilities people, you may have finance, and so forth. And so you do some issue raising, you put that into a decision hierarchy. That comes out, the decision hierarchy is talking about what decisions you have. Some of those things are going to be givens. And they may be given to you by your decision review board, your decision executive. There's going to be those things you're going to focus on, and then there's going to be the things that you can decide later. Now, those focus on decisions, which could be 3 or it could be 20, move into a strategy table. And in that strategy table, now I can identify different development options, scenarios, and draw some paths through there. In the early days, and my early days in decision analysis were 1992, the computers then weren't the computers of today. And so doing these strategy tables and putting paths through there was really important. The computers have gotten much better. Now we can look at many, many paths. But getting this frame right and understanding what we're trying to solve and decisions we're trying to make is really critical.
And I think the criticality of that is you don't do risk analysis for the sake of risk analysis because it's that time of the year to do another risk report. You first have a business decision to make. That decision is uncertain and material enough for you to warrant some extra effort that needs to go into the risk analysis. And then step 0 is to figure out, is that the right decision that we're making in the first place? Are we solving the right problem? And that's the whole framing exercise.
Well, that's right. We need to be able to understand what are the alternatives and be able to compare those alternatives, not just from an expected value perspective, but also from an overall risk perspective. And another key point here is we need to look at them on an incremental basis. In other words, I may have two totally different development plans. One could be a tie back to existing infrastructure. I could put in a whole new platform. Those are completely different. But I need to look at the incremental cost versus the incremental value I get and the risk associated with it. Because it could be that the platform might be more attractive because I can produce more, but maybe it starts 4 years later than having the tieback. And
and that's I mean again. Many companies are kind of on a different stage of their maturity in the decision making. But this stuff it's kind of obvious to some, but it really is groundbreaking. Is for every decision there are always multiple alternatives, and it's not like many organizations do. Is that do nothing or do this way? The alternatives are usually much broader than that. There are multiple alternatives of achieving the same objective. So the decision science kind of teaches us that if we are to properly manage risk when we're making decisions, we have to significantly broaden our kind of typical approach to decision making.
Let me give you another example. There's two big uncertainties in the oil industry. One is, well, how much hydrocarbon do I have? How much gas or oil? And this typically looks something like a log normal distribution, but it actually is not a log normal. It's something else. Okay. And so then there's the price uncertainty, and I can't do anything about the price uncertainty. So the question might be, my alternatives might be, build one great big platform and put a whole bunch of stuff, assuming that I'm going to get a really high production rate, and I don't want to leave anything in the ground. I want to get it out as fast as possible. That's fine. But another alternative would be build something small that have a really long production life, assuming I had a high production. Or another alternative would be, let me build a platform that's large, but don't put a lot of processing material in it, and then wait to find out what the reserves look like, and then be capable of adding additional processing. But I have to make an upfront investment of making that platform bigger to have the space to put the additional processing equipment. So we need to look at this on an incremental basis. I gave you just 3 little examples here, and I need to look at those incrementally. And the right answer will depend upon what is my value measure. We didn't talk about the value measures in the framing exercise, but that's also very important. Is this NPV? Is this rate of return, which would be really kind of a bad thing because you want to come back to NPV at some discount rate, if it's rate of return. Other things that are really bad are earnings or your PE ratio of your stock or something of that nature. So you need to think about what your value measures are. And have a really good understanding about that.
And when you compare different alternatives, what kind of tools or techniques do you normally use?
Well, Chevron uses decision trees quite a bit, and I think that's because there was available to us back in the early 90s some software called SuperTree, which is actually still available from SmartOrg. And so decision trees have been around for a very long time. They're very, very nice, easy to understand. They're typically put together in 3 branches. You can do value of information with them using Bayes' theorem. Most of the software now will do that automatically for you. The problem is that most things are not discrete. I really don't want to represent my reserve distribution as 3 numbers. Which 3 numbers do I use? Do I use a P5, P50, P95, P10, P5, P50, P90, so forth and so on. And so you always have these what you really want to be able to do is do the analysis with continuous distributions. That's where simulation becomes very valuable, because now I can look at this full range of resource.
Yep.
So then the question becomes, well, what tool do I use to do simulation? Well, a data scientist can crunch the numbers all he wants. But unless he can explain it to the decision maker, to the executives, and they act upon the recommendations, all of that number crunching is for naught. Oftentimes that story is told about engineers, but we'll apply it to decision scientists for this interview. So I think what you really need is something that's much more interactive. The crystal ball at risk have been around for a long time. Very good software, very well developed. They've added bells and whistles and cherries and whipped cream and everything else to them and so forth. The problem is they're not very transferable to other people, to, let's say, your subject matter experts. So I really like the concept of the SIPMath approach, which is just using native Excel. And you can see what the distributions look like. You can use them in a meeting, live demonstrations. And when the boss says, "What if?" I don't. The cost would never be that low because the project manager was optimistic. You can actually just go in there and change that number, and you resimulate. Very, very quickly, and have the results. You don't have to tell them, "Well, I'll get back to you with the answer tomorrow."
In 24 hours.
Yes, right. So I think that's the advantage of using simulation, continuous variables, using SIPMath, which gives you the immediate results.
Chevron went on a very long journey from studying back in the 80s and now having decision quality as an integral part, at least for the kind of the bigger, more significant decisions. What are some of the steps or some of the suggestions or maybe advice to make it happen? Because most of the people, most of the listeners, I think they understand the basic math on what needs to be done and how to do the simulations. It's selling that to the executives, so the executives would stop making decisions based on average and actually allow us the extra a day to do the simulation and to show them that there are actually multiple scenarios. What are some of the kind of good ideas from your experience that helped management buy into that?
Well, I think the answer is you need to be able to have an advocate at a middle-level management that can then grow into that executive level. And you train them. And that's why we started this in 1990. With training from SDG, and it took till about 2001, 2002, so it took 12 years for us to train enough of the executives, and they moved up in the ranks to where we could formalize it. And then it became part of our appropriation request. Every company has an appropriation request. You want money, you go to the company. And it became a requirement. Well, then it was ingrained. There's a great video by George Kirkland, who was the vice chairman. He's now retired. That was given at an Informs that talks about decision analysis at Chevron. And he makes the quote that I think has been quoted in universities and elsewhere about decision analysis became part of Chevron's DNA. Right? And that's true. You mentioned the large projects. That's certainly true. But it's also being used for smaller projects. And I think that the key there is using the tools that are appropriate for the size of the project. Not every project has to be a 3-month, 4-month decision analysis, large decision trees. Sometimes just getting through the framing will bring you back to an obvious answer, especially on the smaller ones.
That's perfect. Now, people obviously are very interested in learning more about decision quality. Now, I understand you have a YouTube channel where you share some videos on different steps of the process, the methodology. How will people find it?
Well, that's really easy. You just look up Brian Putt, and you'll find my videos. I try to have my picture on each of the the thing, so it's pretty easy to say, okay, I know who that is.
Yeah, perfect.
And these videos cover a wide range. Some of them are very specific to SIP math. Others are really more applications on cost and schedule risk analysis, value of information. I think I have some on reliability. I have some on portfolio. And most of these videos are using live Excel models I'm demonstrating. And I'm happy to share those Excel models with folks as well. Because I was talking to one of the people here at the conference, and he says, well, Brian, I watched that video 2 or 3 times to make sure I understood what you were trying to do. And so it's kind of like doing risk evaluation is kind of like learning how to type or how to do something in Excel. Initially, it's very complicated, and you got to think about the process. Pretty soon, you understand how to use the tool, and it's just like riding a bike or typing. It just happens. Okay, and that's where you need to get to, and then to be able to understand what displays are really important. So, if I might, I've talked to a number of people about, what do you use to talk about risk? And a lot of people say I like to use distribution plots, a typical normal distribution that you might look at, or that type of a plot, okay? Often, they're skewed.
Yep.
The problem is with those distributions is it's very difficult to compare. And we talked about the importance of being able to compare different alternatives. And what you really like to do is be able to put them on top of one another.
Yep.
And so, yes, you can do that. But I think the more easily graph is the cumulative distribution function, which you can do that very easily in SIP math, and you can combine them very easily in Excel. And I've demonstrated that on the YouTubes.
That's perfect.
The pushback I get is, well, my management doesn't understand what a cumulative distribution function is.
Yep.
Well, if you take 10 minutes to explain how it works and what it is, give a few little demonstrations, they'll get it. I mean, they got to their position because they were smart, okay? Let's treat them as such. And then your life thereafter, for years, will be much better off. And don't start off with a normal curve or something of that nature. Start off with something that may have some discrete values in it so you can see some vertical lines. Well, what does that vertical line mean? Let's label it. What is this upside tail or downside tail?
Perfect. That's wonderful advice. Invest our time into educating executives about understanding distributions, tornado charts. So thank you very much for your time. I'll provide all the links in the description underneath the audio and the video that this will be available. Brian, really appreciate you taking the time. Thank you.
Thank you, Alex.